Hi guys, I'm Sir Kim. I'm back and let's have problem number 14 for today. I am thinking of a natural number. If you add 15 to it, the answer is a perfect square. If you subtract 14 from it, the result is still a perfect square. What is the number am I thinking of? Please pause the video, give this problem a try, and if you are ready, continue with the video, and I will reveal the solution and answer to this in 3, 2, and 1. Let's go. We don't know what the number is. Let's say x is the number that we are looking for. Based on the problem, if you add 15 to it, the result is a perfect square. Let's call that number b squared. So we have here x plus 15 equals the perfect square, which is b squared. We have the second given, it says here, or condition, it says here, if you subtract 14 from it, the result is still a perfect square. So if we have x minus 14, the result is still a perfect square. So let's call that perfect square a squared. You could see I represented them as two different variables because in the first place, they are two different squares. And from here, we could actually eliminate x by subtraction. So if we subtract equation 1 by equation 2, this gives us here the difference at the left-hand side. We have b squared minus a squared. We have this equals x minus x becomes 0. And that's why there's no longer x. There's no more x here. And if you have 15 minus negative 14, that becomes 15 plus 14, or simply 29. Hence, b squared minus a squared equals 29. And this time, we will apply factoring. We could actually see that this 29 here could be expressed as a product of two positive numbers, 1 and 29. Let's use positive natural numbers this time. And we could see there's no more other possibilities except probably if you use negative numbers. And besides, 29 is prime. And so it has two positive factors, namely 1 and itself. And we have to remember this. If you subtract a bigger natural number by a smaller natural number, then the difference is smaller. And if you add them, then of course the sum would be bigger. If we are going to follow this concept, this means that this b minus a is equal to 1, and this b plus a is equal to 29. That is why we have here your two equations. B minus a equals 1 and b plus a equals 29. We could actually see that we could perform elimination by adding both sides. That way, we will eliminate a. So if you have b plus b, that's 2b. Negative a plus a is 0, so we will not write anything here, equals 1 plus 29, which is 30. And in 2b equals 30, dividing both sides by 2, we get the value of b, which is 15. And since we already have the value of b equals 15, we can now substitute 15 to b in our first equation. And with that, by substitution, we have x plus 15 equals 15 squared. And here I also utilize the symmetric property of equality as well. And we have x plus 15 equals 225. Subtracting both sides by 15, we get x equals 210. So which is the required number that we're looking at. Here, you could see that I added both sides to eliminate A. If you wish, you could also subtract both sides and solve for A. And after knowing the value of A, you can now substitute A to the second equation. And I believe that you will still get the value of X, which is 210. So is 210 really the number that we're looking at? Let's try. If you add 210 by 15, that's 225, which is 15 squared. Correct. If you subtract 210 by 14, it will result to 196, which is 14 squared. So you see, 210 satisfies our conditions, and it is the correct answer to this problem. I hope you learned something out of this session. And remember that you have a power to suggest problems for future content. You may reach me in my Facebook and Messenger and in my email here on our screen. And before I end, let me quote Stefan Banach when he said, "Mathematics is the most beautiful and most powerful creation of the human spirit." With that, TYVM, thank you very much and a great day to one and all.